All right, so there was the third one. If you want to look through it, we used what was on the first page. All right, let's go back and now, I forgot we didn't do problem number 2. So we have this 6x plus 7, and then we have all that. So we're going to multiply everything by x plus 2 squared. So that'll give us 6x plus 7 equals, and here we're going to have a times x plus 2, and then b, the x plus 2 squareds cancel, so plus b. This will become ax plus 2a plus b equals 6x plus 7. And so we have an a times x and we have a 2a plus b. So this part right here, this here matches this, and this here goes with that, right? So we immediately know a equals 6 and 2a plus b equals 7. We already know that a is 6, so this is 2 times 6 plus b equals 7. So that's 7 minus 12 is what? And so b is -5. All right, then you go back through and you say, all right, let's make our new integral. Our new integral is 6 over x plus 2 plus minus 5 over x plus 2 squared dx. Okay, and then it's just a matter of doing that integral, which shouldn't be too crazy difficult. So this becomes, the first one is just 6 ln x plus 2, right? But the second one, we have to still do minus this integral here. We can put our 5 out front. This becomes x plus 2 to the -2 dx, right? And how do we integrate that one? Okay, and then what? Then it's just u to the -2. Then it's just add 1 to it, multiply or divide by it, right? That -1. And so after we do all that substitution, we have 6 natural log x plus 2. And then this will be -5, but over, and then x plus 2 to the -1 over -1 plus some constant. I can use c here because we didn't use c up above. And so this is 6 ln absolute value of x plus 2 plus 5 over x plus 2 plus c. That was just terrible. There we go. Okay. Is that what you got? Good. Any questions on either of these? Yep. What do you mean? Does it matter what order you put it in? I mean, if I rewrote this, like let's say I had 6x plus 7 over x plus 2 times x minus 3. Is that what you're talking about? So I would do that equals a over x plus 2 plus b over x minus 3. But what if I'd written a over x minus 3 plus b over x plus 2? Is that what you mean? Like what if I'd flip-flopped them? It wouldn't make a difference. The answer, the value I get here for, say, a turned out to be 2, down here b would turn out to be 2. And then up here, B would turn out to be 5, and down here, A would turn out to be 5, and it'd be the same thing. You'd get the same, you should get the same result. And you might want to check it. It should turn out to be the same. It shouldn't matter. Just switch the order. If you want to send it to me, I'll look at it. Okay, send it to me and I'll look at it. There may be something about the order they're wanting that I'm not understanding you're asking me. So, okay. Any other questions on this? On these? On this one? On this one? What do we think of this one? So we've got 1, 2, I think 3 left to do here. Three left to do. One of them I'm gonna leave for you to do. So this next one, I believe this one is in the textbook. So try, then see the textbook, see your text. Okay, so that one I'm gonna leave for you. This one, do you want to try this one? Do you want me to go through one more of them? Let me see if there's anything tricky in it. So this has the x squared in it. Is that our first ax plus b one? That doesn't have it. So this one, I think maybe, I think I should do this one and then I'll let you do the last two yourselves. How about that? And what's this? Yeah, because you've got, this is, I think, our first one where we have a degree 2 that we can't reduce, right? Yeah. Okay. So if we look at this one, we've got x squared plus 1 there. That's a degree 2 polynomial, right? And so we can't just do a over it. So what we have to do is negative 2x plus 4 over x squared plus 1 times x minus 1 squared. And then what am I going to put over here? What goes up there? Not a. Because it's, well, you're jumping all the way to what it turns out to be, huh? I don't think it turned out to be that, though. What do I put up there? A. Not a. Right? If we go back to our, how do we do this? That's the second step there, right? Is our quadratic there? That's what we're putting on top. That kind of a thing. AX plus B, not just an A, okay? So come back over here, wherever it is. So that's AX plus B. Then we have the x minus 1 squared. So we have to do a C over x minus 1, and then a D over x minus 1 squared. Okay? Everybody with me? All right. So now we have to multiply everything by the denominator, the x squared minus 1. So multiply everything by x squared plus 1 times x minus 1 squared. That's going to give us negative 2x plus 4 equals, and then we're going to cancel out the x plus 1. So this is ax plus b times x minus 1 squared, plus, we're going to cancel out one of the x minus 1, so we'll have c times x squared plus 1 times x minus 1. And then here we'll cancel out both the x minus 1. So we have d times x squared plus 1. Now we need to expand this all out and distribute everything, collect all the x squared terms, all the x terms, all the everything together. Basically go through and do a bunch of distributing and then collecting and all that stuff. And do I need to do all that algebra? Or can I like ... and write what it is? I'm just gonna, is that okay with everybody? Because I'm gonna just, like I'll expand this out, x minus 1 times x minus 1, and then distribute and group and everything like that. So do some steps and distribute and group. And when you do that, you should get a plus c times x cubed plus negative 2a plus b minus c plus d x squared plus a minus 2b plus c times x, and then one more plus b minus c plus d. Okay? And then over here we have negative 2x plus 4. Well, we don't have any, right? We have negative 2x plus 4. And so we can match up the negative 2 with that. We can match up the 4 with that. What do we do about the x squared and the x cubed? Yeah, they're 0, right? Because essentially over here, what do I have? I have 0x cubed plus 0x squared minus 2x, right? Those are just zeros, okay? 0 times it. So we'll get a plus c equals 0, negative 2a plus b equals, oops, not equals, minus c plus d equals 0. We'll get a minus 2b plus c equals negative 2, and b minus c plus d equals 4. Go through in any which way you find most appealing for you, adding these ones, since they're all pretty much just A, B's, and C's, it's usually pretty easy to start subtracting and adding them together to cancel stuff out, right? So that's what I would do. In fact, that is what I did do. So anyway, and you can figure out what they are. Like I did what did I do here? I did A minus, I did equation 2 minus equation 4. So that would be, so if this is 1, 2, 3, 4, if I do 2 minus 4, the b's will cancel, the c's will cancel, the d's will cancel, and I only have left is an a. Negative 2a equals negative 4, and so I get a equals 2. All right, so go through and do stuff like that to solve them all. Do you need me to show you all of it? Like 2 minus 4, negative 2a plus b minus c plus d equals 0, minus, and we'll have a b minus c plus d equals 4, and so this will just be negative 2a equals negative 4, so a equals 2. Stuff like that. I can tell you the other one, and then you can go right back to equation 1 and plug in 2, and then you get c. So c is negative 2, right? Do y'all want me to go through these or not? No one's really answering me. I don't know if you need me to or not. So you go back to equation 1. Maybe I should just bring that all down here. Give myself that left side. So there's 2 minus 4. Go back to equation 1. A is equal to 2, so it's 2 plus C equals 0, which tells me C equals -2. There's C. Equation 3 has A and C in it, so we can just plug those in to get B. So equation 3 is A, which is 2, minus 2B minus 2 equals -2. 2 minus 2, that's gone. And so you get B equals 1. And after that one, you can go to whatever one has D in it, which is either equation 2 or equation 4. Equation 4 only has B and C in it otherwise. So if you go to equation 4, we end up with B1 minus C -2 plus D equals 4. And so D is going to equal 1. Is that right? No. 1, oh, minus -2 is plus 3. Why was I doing? I was doing 1 minus 2. It's 1 minus -2, that's 3. So yeah, D is 1. All right. That means this integral, right? So let's go to a different color here maybe. So our integral is going to become integral of A, which is 2, x minus 2, right? X, what was B? Oh no, B was 1. Plus 1 over top of x squared plus 1, right? Minus, and then we have C, which is -2, so minus 2 over x minus 1, so plus the -2. And then we have D, D was just 1, so this is plus 1 over x minus 1 squared, and then dx. And then you should be able to go through and figure that one out with some u substitutions and stuff. I think even if I use it, yeah, for the 1 over x squared plus 1, I think I used one of the trig ones. Okay, and so do that integral, which you should practice doing, and you should get natural log of x squared plus 1 plus the arctan of x minus 2 ln of x minus 1 minus 1 over x minus 1 plus some constant. What do we think? Wasn't that one fun? Not too bad. I've had to do much worse problems than this.